Hello guys, this is Varlaino. Welcome to the next episode of series of uh, while designing enhances Maxwell for wireless power transfer. The purpose of this session is to explain how, if we select solution type AD current, how the response of um, our simulation will be after we run the simulation. The parameters we are interested to know in this session is the self-inductance, the mutual inductance, the resistance of primary coil, and also the resistance of the secondary coil, the coupling coefficient between the coil itself and also between the primary and secondary side. And we are also interested flux parameters. One by one, I'm going to discuss. So let's start with what we did in the last section. In the last section, we discussed how to model this primary and the secondary side, whilst the core, and how to once you did the modeling part. Actually, the clue is as follow. You will model your primary side, in secondary side, in the core in the primary, and the core in the core in the secondary side. After that, after modeling, you have to go for boundary condition. Once you did boundary condition, you're going to go for excitation. In excitation, you're going to inject current in the primary side and also inject current in the secondary side. Once you injected the primary side current and the secondary side current, then the matrix will be chosen here, like this one and this one. Once you choose the matrix, then what are you going to do is then you click OK, and then parameters. And for parameters, actually, I have chosen two matrices. I'm going to delete one. Then for mesh operation, you're going to select the mesh operation because the mesh must be formed in the boundary we have selected. Then what we are going to do, in the boundary, you can see I have chosen 200 mm. It is based on your experience and based on the quality, the nature of understanding how to select the maximum length. So then what you're going to do for solution type, you're going to go here. I have chosen a maximum number of passes is 15 and percentage of error is this much. So this is as per default, and also the solver I inserted 85 adaptive frequency, and also for frequency sweep I got from 84 kilohertz to 86 kilohertz, and the number of steps are 400 hertz. And I should mention that when you're selecting here, if number of sweep step is less, in that case, you're going to have less time to run. Means it will not take them. Your system will not take that much time. But if your system is better and the configuration of your machine is good, you can go for more steps. So then after this analysis solutions step, I should also tell you that this one is for solution. Our solution type here is a current, so you can see from here. Next one is the optimetrics. Like what are you going to interested if you want to change the distance, independent variable, and if based on the independent variable you want to get the dependent variable, which is the mutual inductance, also applying coefficient distance. So for that, you're going to go to table and then click add. Sorry, this is not okay. 1 minute. Just take this one, then delete. Okay. For if you want to add a new, uh, if you want to add new parametric matrix, then you just click add. Then from here you can change as we know we have two parameters here. One is dx. Dx is the uh, mm, changing parameter between primary and secondary, means the distance swap, and O is the current. Then here you're going to start from how much distance you want to start to how much distance you want to go. And the step for this one is whatever step you take, small or big, it is up to you, but you should all the time remember, if you have a lot of steps, it will run bad if your system is not good. It at the end of the day, if maybe I have the experience of I ran one program, one simulation, and this simulation took me 48 hours, and at the end of the day, it got terminated without any result, and it took 200 GB of my laptop. So that's why I'm just suggesting that if you want to get better result, you just go in the about to you have to go about to the point of interest. Means if you want inductance for 50 you just go from 40 to 60, I mean lesser. Okay, as I have done already, I'm not going to discuss this one. After that, once you did, then you can go for solution type, solution how. Once you run the simulation, for running the simulation, just you will go here, then validate. But after validation, then select, you can put, you can click, sorry, analysis all. The analysis all will take out the solution for you. After, because I have done already, then I'm not going to go there for that. I'm going to directly discuss the results. For results, just you double click here it is the results. Sorry, the double click, just right click it and then go to the data table. Once you go to the data table, here we have the matrix. You select matrix from here and the parameters you're interested, like for changing distance. Based on the changing distance, if you want to get the output, just select dx here. Then we can find a inductance, you can find coupling coefficients, you can find the resistance of primary coil and secondary coil, whatever you want. You are interested in magnetic flux, you are interested mm, I mean whatever you like, you can go and check for losses and whatever. So I just already took the results here. Just click double, then one table will be listed here. Then double click the table, you will see as the parameters in the, so let's assume the axis and the x and the x-axis, and the interested part, which is maybe tx transmission side, which I took as tx, and the receiver side I took as the rx. Suppose this is the mutual self-inductance between the primary coil. See, as you change the distance, you will the mutual inductance will change. And also here the coupling coefficient for as between the coil itself is 1 in the primary side and in the secondary side. And also here we don't have coupling coefficient for primary and secondary. And then I took another table here, coupling coefficient. The name is coupling coefficient. If you double click, you will see this is again the swap in the dx, and this one is the result you will get. As I have time limitation,